Hello, this is a quick video to show you how to figure out the shape of a population distribution based on looking at a box plot from sample data. So I'm going to change the sample size to 500, which is the first sample size requested in the project. Just a reminder to put your name in the name box before you get started so I can tell that it was you and that it was recent. And then you can go ahead and click Start Quiz, which will lock in your name and the date and time. And then when you go to look at these, at first sometimes people are confused by how to read this, but what you want to remember is that this is Q1, the median, and Q3. And the job of those three numbers is to split a data set into 4 equal parts. So this part on the left has 125 data values in it, 1/4 of the sample size. The left side of the box has 125 data values in it. The right side of the box has 125 values, and then from the edge of the box all the way out here to the last outlier, that's a total of 125 pieces of data. So when things are narrower, that does not mean less data. Every section has the same amount of data. It means the data is more condensed, and when the data is more densely packed in one area, it's going to pile up more. I'm going to click on Show a dot plot so you can see that, but we should expect the data to stack the most in the narrowest area, and then here and here it won't be quite as tall, and over here it will be more spread out because 125 pieces of data, but a lot more room for that. So if you click this during the actual quiz, you do lose 0.4 off of the total, so you want to try and do this without it, but I'm going to show you on a couple of them. So notice the narrowest section here was the tallest part of the graph. And then this is a little more spread out, so that it ends up dropping down to a tail. Here the peak is dropping as well as the data is more spread out, and then as it gets more spread out it continues to drop, forming a long tail on the right side. So if you just look at this, peak here, longer tail on the right than on the left, but still a decent slope down here, you would say that that's probably a left skewed population, so you would go select that. The key is you want to be able to do that. Oh, right skewed. Silly me. Learn from my mistakes, right? The tail is on the right, definitely right skewed. Hopefully it makes you feel a little better to see me make a mistake like that. So move this around so we can see it, right? So how do we know it's right skewed? The longer whisker is like a long right tail. The shorter whisker on the left is like a shorter left tail. So you have this longer tail on the right than on the left, so it's going to be right skewed. I'm not sure what's going on with my day that I called it left skewed at first. So here's another one. This one can be a little tough because you're like, wow, these are all about the same width. Okay, so if they're all about the same width, then the data is spread out about the same in all 4 of these sections. And what kind of data has the data spread out the same all the way across? That would be uniform. So what we would want to do is pull this down, select uniform, and get full credit, but I'll show you the dot plot to back that up. So lots of peaks and valleys all over, which is not the level flat of uniform we expect. But with a sample size of 500, there's still a lot of random variation in there, distorting that a bit. But no clear peak anywhere along. The peaks and valleys everywhere, that's a reflection of uniform. Here, look for the narrow spots, because that's where your peaks are going to be. So narrow here means that we have the peak in this area. And then long on the left, so tail on the left. Long on the right, so tail on the right. So peak in the middle with the tail on each side, that's bell-shaped. Let me show you the dot plot to back that up. Peak in the middle, tails on each side. Again, you don't want to do these dot plots all the time, because if you do that, you're going to get a deduction off your score and you won't get the score you need, but it's good when you're practicing. I usually try and think about the peak first, and that's the narrowest section. So the narrowest section here is on the far left, and then it gets a little wider, and then really wide. So peak on the far left, and then dropping down, and dropping down even further. So if the peak is on the far left and a tail on the right, that is a right exponential. Peak on the left, tail on the right. Okay, I could click that, I'd get it right, but I'm going to go ahead and show you the graph. So that looks maybe a little severely right skewed because the peak's not at the very edge. You can't tell that in the whisker, but actually I think that's just a random variation, that it really is right exponential. The peak would probably be more around here if it was severely right skewed. So I'm still going to go with right exponential. Let me go ahead and miss one here to show you some things. So This looks like just the reverse of that basically. So you've got this little narrow section here, so that'll be the peak. Then it gets a little wider and really wide. So narrowest is the peak, wider is going down, dropping down, and then tailing off. So peak on the right, tail on the left is left exponential. But I'm going to put the wrong answer, severely left skewed. I just want to show you something that happens. So one of them, it gives you partial credit on this one because you were close. Left exponential and severely left skewed are pretty close to each other. So it's going to give you some points on this one if you get a neighbor. So that's kind of nice. And then we'll go ahead and click OK. Alright, so that's kind of how that works. I'm going to go ahead and hit clear and then just show you with 100 and do a few of these. It gets a little harder here, but not as much harder as it did with histograms, I think. There's a little more random variation, so you can get fooled sometimes by the data, but you're still looking for the same things. So this and this section are the two narrowest ones. So our peak is on the right. Here we have things the most spread out, so a tail on the left. So this is one of two things. If the peak is here, it's severely left skewed. If the peak is here, then it would be left exponential. Typically, if it's left exponential, this will be noticeably narrower than the box, the whisker narrower than the box next to it. So I think the peak is really here. So I'm going to go with severely left skewed. If it said left exponential, that wouldn't be shocking because these two are looking pretty similar to each other. But I'll do severely left skewed, and it looks like I was right. This is a tough one because we have a narrow section here, which would be the peak, I would think. And then this is wider, but then this is narrower. So are there two peaks? Could be, I guess. A longer tail here kind of counters the fact that this is narrow. So this one's confusing. I think this data set has a lot of random variation in it that is kind of abnormal and is throwing us off from the truth. Since I have a tail on the left and a peak near the center and kind of a distorted tail on the right, I think this is probably bell-shaped, but it's just a lot of random variation not making that clear. I wouldn't recommend doing this too much. If this was me and I was taking the quiz, I'd just give my bell-shape a try and hope I was right. But if you're really nervous about one, you can't use this too often, but maybe once or twice, you could look at a dot plot first. And now that I've seen it, this doesn't look bell-shaped to me. So I'm glad I decided to cheat and take the deduction. Because there's kind of data all over the place, I guess this is uniform, just not uniform enough that it reflected very clearly on here. That's not too surprising if I was having a hard time figuring out where the peaks were, that maybe there wasn't a clear one. So now that I've seen the dot plot, I would say uniform, and then I would try to remember, okay, when there's a little bit of chaos in my box plot and it's hard to figure out where the peaks and the tails are, maybe it's uniform. Alright, this one is a little easier. We've got very skinny whisker, skinny here too, then getting wider, and then get really wide. So this is either severely left skewed or left exponential. With both of these being so narrow, that seems to reflect very tall on the right and then getting quite a bit lower on the other side. So I would go with left exponential on this one. If you put severely left skewed, I would understand, but with so much of the data, remember this is the median, so half of our data is in this little section and the other half is spread out all over this. With so much data on the far right, that seems like it would be left exponential. And then this one, narrowest, wider, wider, wider still, right exponential. This is one that like freaks people out at first, but it's actually an easy one. Very narrow whisker, so there's a peak on the left. Narrow whisker over here, so there's a peak on the right. And in the middle, the data is more spread out, and we only have one type of distribution with a peak on the left, peak on the right, and low in the middle, and that's U-shaped. And I'll stop with this one right here. I'll go ahead and select it so that you can see if I'm right or wrong, and then I'll go ahead and stop. You need to run it all the way through and make sure you get at least 9 out of 10. Seems like the peak is here because that's the narrowest section of the graph. Much longer tail on the right due to the longer whisker and outliers. A little bit of a tail on the left, definitely wider than this part of the box. So this one is either right skewed or severely right skewed. Could be either. I'm not 100% sure. The good news is if you mix those two up, you get partial credit. I'm going to say that this tail is long enough that it's probably forming a downward slope, and go with left exponential. I could cheat and do the dot plot, and that might help, but the cost of doing the dot plot and the cost of missing and getting the neighbor is the same, so I might as well take a guess and maybe get it right. I think that with the peak here and a reasonable tail on the left, this is probably right skewed rather than severely right skewed. So let's see. You can't see it here, but I'm crossing my fingers. Okay, it was severely right skewed. So, but we will get partial credit for that. Our score is going to go up from 4.6 out of 5 to 5.2 out of 6. So the penalty for guessing and missing a little bit is the same as if we had shown the dot plot. And then conveniently, we're getting kind of shown just by coincidence, random coincidence, the one that we just chose. It looks like if it was right skewed instead of severely right skewed, there would be a bit of a longer whisker and thus a longer tail on this side. Not that different from what we just saw, but a little. The peak is a little further to the right with a little longer tail on the left, but definitely a longer tail on the right, represented by the longer whisker and outliers. So this one is what right skewed looks like when it's not severe. And I'll stop there, and you can speculate on this one on your own if you want, but I'm going to stop the video. Good luck on this. Try not to get too frustrated. Think about where the narrow parts are and the wide parts are, so you're thinking about peaks and tails. All right, good luck.